Welcome to Contact Point, the podcast that brings together specialists from TTI and our supplier colleagues from Phoenix Contact with discussion, information, and insights on the newest technologies helping the world move to an all-electric society. And now, Contact Point.
Thanks, Jim, and welcome everybody to the next installment of Contact Point, a podcast for TTI and Phoenix Contact. I'm your host, John Sandy from TTI, and joining me today is Clint Hommel from Phoenix Contact. Welcome, Clint.
Hey, thank you so much for having me. It's a real pleasure.
It's great to have you on. Why don't we start? Why don't you just tell us a little bit about yourself and your role at Phoenix Contact today?
Yeah, sure. So my name's Clint Hommel. I am the Associate Product Marketing Manager for our energy monitoring solutions at Phoenix Contact. I have been with Phoenix Contact for a little over 12 years. And I currently specialize in monitoring. I do have a diverse background in a lot of our industrial products, from signal conditioners and relays, and of course terminal blocks and all the other wonderful things Phoenix Contact does. But yeah, now part of the power reliability team, specifically focusing on energy monitoring.
I've got to imagine, Clint, that having that sort of background with that sort of experience really does help when you're sort of getting into a specific product. You really get a view for where it fits in the overall scheme of things.
I can say it has certainly been beneficial to help understand customer applications, to look at it a little bit more holistically than a component level solution. What is the system doing? How can we make it more reliable and more efficient? Certainly viewed through the perspective of not just my own product offerings that I'm responsible for, but as a whole, what we can bring to the table.
Sure, I see that more and more with Phoenix. Obviously, the range is you have pretty much everything covered there, and it's very interesting to see how it all goes together. So if we're talking specifically today about energy monitoring, why don't you just give us an overview of the kind of markets and applications that it gets involved with?
Yeah, so if you could see my face, I'm smiling right now because when you're asked which market segment energy monitoring is in, the most generic answer I can give you is all of them. The electricity that we use to make modern life possible in every capacity, electricity touches everything. And all of those systems, all of those interconnections are all opportunities for monitoring. So the question is why, though? What does it bring to the table, right? And with energy monitoring, there's a plethora of benefits, from small to, quite consequential, whether we're talking about energy savings or in the industrial realm, many times a reliability aspect.
Yeah, and that leads very nicely on to trying to establish and for our listeners' point of view, outlining what is the importance of energy monitoring, particularly as it, I guess, relates to industrial applications.
Yeah, for sure. So I like to break it down into, three kind of high-level benefits or reasonings, if you will. One of them being efficiency. That's kind of one thing that most people think of when they hear energy monitoring is efficiency. And it's certainly a great goal to achieve, right? Happy equipment runs efficiently. Its energy consumption is optimized. It's kind of like your car. If your tire pressure is low in your car, you're going to use more fuel. If there's something wrong on your machine, you're going to use more energy. So efficiency can be not only a tool to reduce overall consumption, but a tool for compounding savings from the ground up. We also look at reliability in general. So reliability is a huge reason to invest in energy monitoring, especially if you're running equipment that has high production value. You might have a line that produces $10,000 of revenue per hour and, 4 hours of downtime or days of downtime because a critical component has failed is just really an unaffordable mistake. So looking at the condition of the machine over time, tracking it, making sure that energy consumption is not increasing over time, which would indicate a wear item, or on the opposite end of the spectrum, something fails instantaneously and the power consumption goes very flat. There's a number of use cases there. And then kind of the last pillar of why we see industrial customers doing energy monitoring is kind of having a log or accountability of what's going on. You may be operating facilities that are buying hundreds of thousands of dollars of electricity from utilities a month. You may have some cogeneration on site. You might be producing some of your own electricity. You might be managing the peak demand that you're putting on the grid. All of these are reasons that you would want to track how much energy you're producing, how much energy you're consuming, but also looking at things like what's the quality of the voltage that we're getting from the utility, because there are implications for the health of equipment depending on the quality of the utility connection.
Yeah, all really, really good points. And if you were going to sum up, just for the listeners, talking about energy monitoring and key benefits, what would you say are the top three benefits?
Yeah, reliability, accountability, and efficiency in 3 words. So looking at uptime, looking at energy savings, aka cost savings, and a little bit of protecting yourself in the event that you have a utility dispute, whether it's from voltage issues or from a billing perspective on energy quantities.
Okay, and now maybe let's dig into an energy meter itself, Clint. And I guess from our listeners' point of view, there may well be some people on here who are wondering exactly what an energy meter is. Why don't you give us a quick definition of that for the listeners?
Yeah, so an energy meter is going to measure voltage and current, and from that, it's going to calculate a range of values. In particular, when we're talking about AC power, we would be looking at volts, amps, power factor, power, VARs, all those AC values. But an energy meter also does power tracking, or tracking consumption rather. So energy usage over time, kilowatt hours, is what we're billed for. So an energy meter at a high level is an AC power sensor. It's giving us a lot of data from that, and it's also tracking our consumption over time.
Yeah, I like that AC power sensor. That gives me a much clearer picture and an image in my head. So that's an awesome definition. So what types of energy meters are out there, and what are the best ones to use in industrial applications?
Yeah, that's a great question. I love that question. So energy meters are really, in my mind, split into 2 domains. One is a tool that we would use for everyday monitoring. So looking at macro trends, what's happening over the scale of seconds, minutes, hours, days, months. That's the True Blue energy meter. It's going to track consumption and all these basic data points that we would trend. There is a more specialized subset of energy meters called power quality meters. And a power quality meter is working on the opposite end of the time scale. That's something you're looking into at the millisecond, microsecond, nano or picoseconds in some cases of data. And that's way more of a tool that you would use for tracking, surge issues or transient voltage issues from utility company. With that capability, though, comes a lot of cost. So in general, for an industrial user, most of their meters, they can go with the lower cost everyday energy meter instead of that expensive power quality meter.
So really a key point there is that specifically understand what it is you're trying to do and what your needs are, and then try and pair that the very best with a product that does all that for you, but probably keeps the cost to a more manageable, lower point if you can go that way. There isn't kind of a one size fits all.
Yeah, that's a great way to put it. There's really no Swiss Army knife of energy meters or even monitoring solutions. Sometimes the energy meter itself might be a little too much for what you're trying to achieve. There is a spectrum of solutions from very simple current and voltage sensors to monitoring relays all the way through these high-end, power quality meters. So it is really a question of what's the criticality of the system and what's the payback for investing in, whatever level of equipment we're putting in there.
So if I was a customer today, Clint, and I was looking through what you guys at Phoenix can offer and wanting to talk to someone about getting a best fit for my application, what would you recommend they do?
Our portfolio, as we kind of hinted at earlier, is quite extensive. We do have a sales network of sales engineers throughout the United States. I believe we're around 250 field sales personnel. So lots of experts in your area that you can connect with on a local level. We also have a plethora of BDAEs, or business development application engineers, specializing specifically in our power reliability solutions. So that would be not only the monitoring stuff, but power supplies, surge protection, breakers. They can help you support not only existing applications, but help you build a robust system on the front end, incorporating a lot of those products. And of course, our tech service. We offer free tech service. They're available Monday through Friday, 8 through 5, or I believe 8 through 8 on Mondays, and Mondays through Thursdays. Totally free, no cost obligation. We have power reliability experts on call that can help you with selecting products, with supporting them, with getting started with them, or anything in between.
Thanks, Clint. That's what I was trying to get at. There's a lot of support there. Obviously, you can utilize your TTI local branch, your local branch product managers. There's a team of connected business development managers around the country as well that actually work for me that can help coordinate this. But needless to say, there's always going to be somebody there who can answer your questions and give you better direction. So thank you for that. I guess the next question in my mind is, how can energy monitoring enhance system reliability and efficiency? And which really comes down to, again, expanding on why I'm using an energy monitor.
Yeah, I think we've done enough service to the broad concepts of what monitoring can bring to the table. It might be helpful to explain through an application or two if you're okay with that.
That sounds perfect, Clint.
Yeah, so we have certainly so many application stories that I get in trouble when we're doing live trainings, because I like to tell a lot of stories about monitoring. I think it's the easiest way to relate to what is going on. So one of my favorites we'll talk about is a customer that was doing manages high-rise apartment buildings and commercial buildings in the Cleveland area. And they had an issue at one of their facilities where the HVAC motors kept burning up. We're talking about motors that cost roughly $10,000 a piece. So when you're burning up the first motor, you can write it off as a fluke. A few months goes by and the replacement motor burns up. That's not good. Maybe we should start looking at this. So they called the utility company, and the utility company says, hey, everything looks good on our side. And the customer said, okay, well, we're going to implement some monitoring then, because we need to get to the bottom of this. And they picked an energy meter, specifically our M-Pro energy meter. They paired it with one of our PLC-based data loggers, and they just started recording all the parameters they could, voltage, current, power, once a second. And a few months goes by, and lo and behold, the third motor burns out. And this time, they had a data log that they could go back, and they looked at it, and they discovered on a Saturday morning that the utility company was delivering about 430 volts to their facility instead of 480 volts. Well, electric motors only like plus minus 10% of their rated voltage, generally speaking. So when you put too low of a voltage on the motor, it draws excessive current. It burns up the motor because it gets hot. And that's exactly what happened here. But this time they had a data log that said, proved the utility company had an issue there. And the utility company agreed and ultimately reimbursed the customer for about $50,000 for the cost of the motors and replacements. They had about $3,000 invested in the integration of the meter and the data logger and the monitoring solution in total. So great ROI there, and a great example of protecting yourself against what is assumed to be known good power, but is not necessarily always the case. And in that particular application, the utility ultimately did some investigation and found another customer was using large quantities of power on Saturdays because the electricity rate is cheaper. So it's just kind of a perfect storm scenario that without monitoring, the customer would have been on the hook for $50,000 and more potentially, because the utility never would have caught that issue doing their typical 9 to 5 Monday through Friday investigation.
Yeah, just a good example. I like that a lot. I mean, it's one of those things where data is king, and if you're not collecting it, then you really don't know, and you're in somebody else's hands. I've got to guess moving forward, if they were to do that process all over again, they'd probably incorporate an M-Pro and a PLC data logger from the beginning.
Absolutely. We're working with plethora of customers who are of that same mindset now, especially as cloud solutions become more available and getting that data out of that local facility and into the hands of facility managers remotely. It's really been a game changer.
Well, Clint, I know we're coming to the end of our time here today. Just before we wrap this up, is there any final thoughts you'd like to leave our listeners with, or maybe questions that they need to be thinking about themselves as they move on to their next project?
Yeah, I think when I think about monitoring, I think about pain points. So if you find yourself, asking, well, what happens when this particular heater element fails, or if we lose this power supply, it causes XYZ problem. Those are the types of things that you can monitor even at a low cost that have a high impact. There's a ton of application stories, as I mentioned, that we don't have time to go through today, but if you want to learn more about it, certainly reach out to us. We would be happy to analyze your system, to listen to your issues and your problems, and come to a solution that will help you out.
Well, Clint, thanks very much. Appreciate that. And
my pleasure. Thanks for hosting.
Well, thank you, everybody, for listening to Phoenix Contact and TTI Contact Point podcast talking about energy monitoring. Join us again for a new up-and-coming episode of Contact Point coming soon. And join us again. Thanks very much for listening.
Thank you for joining us today on Contact Point. Keep up with the latest episodes on tti.com/podcasts.